What's up, my people? This is Mr. Toohey, creator of the Accuplacer Math Crash Course series. And in this video, I'm going to teach you how to solve a variety of question types from the Accuplacer Math Advanced Algebra and Functions section of the test. Of course, we'll be using my unique and powerful test-taking strategies that simplify the questions. Oh, and by the way, if you like this video, you definitely want to get access to the full version of the course. Just click the link in the description below to get access. In the meantime, sit back, relax, and enjoy these questions from the Accuplacer Math Advanced Algebra and Functions section. Accuplacer Math Crash Course. This is Mr. Toohey. We've got a student with us today. This is Bree. Say hi to everybody, please, Bree.
Hi.
Thank you, Bree. Appreciate it. And so I've had some students reaching out to me with some questions about the Advanced Algebra and Functions section of the test. And there's just a few higher level concepts that I want to go over with students, and just a few new question types that we're seeing on some of these practice tests, and I just want to go over absolutely everything. So this is an update of the course. If you're not taking the Advanced Algebra and Functions section of the test, you don't have to worry about this. But if you're taking it, you definitely want to watch this. Some of this is going to be familiar, some of the same strategies we've been using, just on a little different looking questions. But there's a couple new concepts as well that we need to go over. So we're going to go over everything. We've got a question up on the screen. This is question number 0. I had like 1 through 8 prepared for today, and I realized I needed to add 1 at the very beginning. So I call it question number 0. So that's why that's there. But I want you to read question number 0 for us, Bree, and we'll solve this one together.
X over 3 plus 3y to the power of 2.
Yeah, equals something, right? So this is an equivalent expression question, right? This expression here in the question equals one of the answer choices. Okay? And now there's an algebraic way to do this. Are you familiar with foiling, Bree? Is that a term you're familiar with? What it means to foil?
No.
Okay, we might talk about that a little bit here later. If you're familiar with foiling, you can solve this just by squaring that expression in parentheses. I'll show everybody watching the recording what that looks like exactly here in a moment. There's an easier way to solve this with just plugging in values, right, which we've been doing all the way throughout this course, and that's probably the best way to solve this question. So we're going to create some values for x and y. We're going to plug those values into this expression in the question, and then we're going to plug those same values for x and y into the answer choices, and the right answer will match up. Does that make some sense, Bree?
Yes.
Okay, we've been doing that. Yeah, we've been doing that all the way through day 3, day 4, heck, a lot of day 6 as well. So let's create some values for x and y. What values are we going to plug in for x and y here? Do you have any idea?
1 or 0?
Yeah, 1s and 0s are great. Now, here's the deal. Notice that in the expression, in the question, we've got x over 3. So it might be tempting to plug in a 1 there. Maybe 0 could work, because 0 divided by 3 would be 0. But I'd probably plug in a 3 there for x, because that's just going to get rid of the fraction. Okay, what's 3 divided by 3, Bree?
1.
It's 1, right? So if I plug in a 3, the fraction's gone. Now 0 would get rid of it as well, but I think if I plug in a 3, that's going to help differentiate the answer choices a little bit more. Does that make some sense? While plugging in a 3 here is actually easier than plugging in like a 1 or a 2.
Okay, that makes sense.
Yeah. Now, I love 1s and 0s, right? And if you want to start there, you could do that. I'm not sure if you plugged in a 0 if you'd be able to get rid of all the answer choices, but I think you can if you plug in a 3 for x. So we'll start there. So x is 3, and then what are we going to plug in for y?
Would we do a different one?
We could. I'd keep it smaller. I think 1 would work here for y.
Okay.
You could maybe also plug in a 0, but again, this will help us differentiate the answer choices here by plugging in a 1. And there's no harm in trying, if you want to start with 0 and 1, that's fine. If it doesn't, get rid of all the wrong answers, then you plug in different values. But I know 3 and 1 are going to work here. So let's do this. Let's plug in these values for x and y into the expression in the question. Okay, and let me see you do this on the whiteboard. And then we'll calculate what this expression in the question equals when x is 3 and y is 1.
Okay.
Work that out.
So would I go ahead and just do 1 instead of this 3 over 3?
Yeah, if you want to turn that into 1, that's fine. But that's what you're doing, yeah.
And if I do 3...
Love it. Great use of the parentheses there. Now, I got to stop you real quick, because this whole thing is being squared. All this. Does that make sense?
Yes, because it's in the original equation.
Yeah, in the original expression, right? Yeah, that whole stuff, the whole thing is in parentheses. So if you didn't have that bigger set of parentheses right here, then you'd only be squaring. Really, you'd only be squaring the one if you didn't have those parentheses. Does that make some sense?
Yes.
So you got to include the parentheses there. Okay, so let's simplify this. And this, I just think in terms of PEMDAS here, right? Let's calculate what's inside the parentheses first, then we'll do the exponents after. So what does the stuff in parentheses equal, Bree?
3.
Well, this right here is 3. Correct. But then,
okay. So I was looking at the parentheses,
the 3
the
times
1.
1. Yeah, gotcha. Yeah. So that's 3. But then we got to add the 1. So what does that give us?
4.
That gives us 4. And we still have to square it. Does this make sense?
Yes.
And what does that give us?
16.
That gives us 16. Absolutely. Questions about that? Or does that make sense so far?
That makes sense.
Okay, good. So we know when x is 3 and y is 1, the expression in the question equals 16. So the right answer also has to give us 16 when x is 3 and y is 1. Does that make sense?
Yes.
Okay, great. So let's plug in these values into the answer choices. And let me see this on the whiteboard. We'll start with answer choice A. And right now, just plug in like a 3 for x and a 1 for y. I just want to see it kind of laid out. And
okay.
Then we'll simplify it later. But right now, just plug it in. Perfect. Looking good, looking good. Great. All right, let's simplify this now. So this is, let's think in terms of PEMDAS. There's nothing to calculate inside the parentheses. We could do the exponents next.
Oh, that's
So what could we simplify here?
We're simplifying. So, I mean, are we doing like the division, like 3 to the power 2?
Do you want to review PEMDAS real quick? Are you familiar with PEMDAS?
Yes.
Yeah. So let's take a look at that real quick again, kind of how to approach that. It's on that rules document. So PEMDAS is parentheses, then exponents, then multiplication, then division, and lastly addition and subtraction. Okay? So if we go back to the expression here, there's nothing really to calculate inside the parentheses. I mean, 1 is 1. There's nothing to calculate there. So next I would go to the exponents in the expression. So we've got like exponents here. We've got 3 raised to the power of 2, and then we've got 1 raised to the power of 2 here as well. So I'd probably simplify those. Does that make sense?
Yes.
Okay, so let's simplify those. What does that give us?
A 9.
Mm-hmm. And I'll just replace
over
that.
3.
9 over 3. And then what's 1 squared?
1.
Just 1, yeah. And then, good, that's it. We've taken care of the exponents. Now we could do multiplication and division. Doesn't matter which one we do first.
The first one.
Yeah, what's 9 divided by 3?
So do the division first?
Yeah, we could you could do multiplication or division. It doesn't really matter, actually.
So 3?
9 divided by 3 is 3. What's 3 times 1?
3.
3. And 3 times 1, once again, is also 3.
Yes.
Now we can do the addition and subtraction. It's all addition here. So what's 3 plus 3 plus 3, Bree?
9. 9. Sorry.
Yeah, you got it. Absolutely. That's 9. Okay, so what do you think about answer choice A?
No.
No, definitely not, because the right answer's got to give us 16 for these values. Questions at the moment?
No.
Okay, that's a little tricky. And I've had students reach out to me before, and they're like, "Wait a second, I saw you divide, first before multiplying." And keep in mind, like division, in a sense, is just a form of multiplication. In a sense, like dividing by 3 is the same as multiplying by 1/3. So it really doesn't matter whether you multiply or divide first. I'm just kind of going to order from left to right. Also, with adding and subtracting, it doesn't matter whether you add or subtract first, as long as you're adding or subtracting as your last step. Because really, subtracting is the same as adding a negative number. So it's, in a sense, kind of the same type of operation. Does that make a little bit of sense?
Yes.
Okay. All right. So let's plug into answer choice B. And I'll clear some space here on the whiteboard. Let's just see what happens. looking good, looking good. All right, looks great. Let's go through that PEMDAS process again. Start with the, there's nothing to calculate in the parentheses, so let's go to the exponents.
Okay. The 9 for the 3 to the power of 2.
Yeah, that just becomes 9. And then that 1 squared, of course, is just
1.
Just 1. So what is that going to equal?
Are we doing the division first?
Yeah, it doesn't really matter here. I would probably just go left to right. Yeah, we can do
1.
9 over 9. Yeah, that's 1 plus, and we've already done this, right? That's just 3 plus 3. Is that pretty clear?
Yes. Yes.
Okay. Does that equal 16?
No.
No way. So answer choice B is gone. Let's try answer choice C. Same thing here. We're just plugging in a 3 for X and a 1 for Y.
I feel like this would be it.
Okay, good. Let's do the exponents first. 3 squared is still 9. We're trying to put that together. I think we're good there. And then 1 squared, of course, is still just 1. What's 9 divided by 9?
1.
1. So that's going to be plus 3.
Got it.
Plus 9 times 1, which is 9. Does that make sense so far?
Yes.
Is that 16?
Nope.
No, it's not. It's not. It's 13. So it's not C. I sure hope D works. I think it does. I don't have the answer key in front of me, so I'm hoping this works out. But I'm pretty sure it will. Let's plug in that 3 for X and a 1 for Y. See what happens.
So we'd have 9 over 9 again.
Yep, I'll write it out for you. 9 over 9 plus what?
And do you want to do the power first, or go to this left to right?
Yeah, we know 1 to the power of 2 is just 1, so.
It's 1.
Yeah.
Okay. So 2 times 3, 6.
Mm-hmm.
And then 6 times 1 would just be 6.
Yep.
And then 9 times 1 is just 9.
There you go. Okay, and that 9 over 9, of course, is just 1. I think that's pretty clear. Does that give us 16?
Yes.
Sure does. Answer choice D. Woo! There it is. So that worked out. Questions about that, or does that make sense?
Yeah, that makes sense. So I'm just picking the best numbers to plug in that's going to actually I guess give me a whole number. And
yeah, you want to get rid of, the answer choice that don't work for those values and confirm the right one. I mean, if you picked some different values, we talked about plugging in a 0 for X, like right off the bat. And let's talk about that real quick. I'll kind of guide you through it here. But let's say we picked different values. Let's say we did 0 and 1, right? So we plugged in a 0 for X and a 1 for Y, okay? It'd be a little different question. What would the expression in the question equal if X is 0 and Y is 1? And let's maybe plug it in. Let's see what happens.
Okay.
And then, well, you've got to square the stuff in parentheses here, right?
Yes.
And then Y, I think Y was 1. So I'm going to change.
Oh, okay.
Does that make sense? I just changed the values up here. If both are 0, everything's going to be 0. Yeah. Okay. So let's simplify this. So we'd calculate what's in the parentheses first.
Just 3.
So it's just going to be 3. Yeah.
Plus 0.
3 plus 0. You got it.
And then that would give you 3 to the power of 2.
You got to square it. Exactly.
9.
Which is 9. Beautiful. Great job, Bree. Great. All right, so when X is 0 and Y is 1, the right answer's got to give us 9. Does that make sense?
Yes.
Okay, great. Now here's the deal. Look at these. Look at answer choice A. Notice because x is 0, if we're plugging in a 0 for x, like right here and right here, 0 divided by anything is just 0. Is that clear?
Mm-hmm.
Yeah. And 0 times anything is also 0. So basically, these terms with the x's sort of disappear from answer choice A.
Yeah.
Does that make sense?
Yes.
Okay. And then if we're plugging in a 1 for y in answer choice A, we'll get 3 times 1 squared. Do you see that?
Yes.
And what's 3 times 1 squared?
1. Oh.
Yeah, 1 squared is just 1,
One,
right?
and then
So, yeah.
3 times 1 is 3.
3 times 1 is 3, not 9. Does that make some sense?
Yes.
So it's not going to be A. And then B is the same thing, essentially. Because if we're plugging in a 0 for x, that term and that term, those are going to disappear. They're going to be equal 0. So we get the same thing here. We get 3 times 1 to the power of 2. That's just going to be 3 times 1, which is 3. It's not 9. So by plugging in a 0 and a 1, you can narrow it down to C and D. By plugging in a 0 and a 1. Does that make some sense?
Yes.
Okay.
Especially like if we didn't have a calculator.
Yeah. Now, if you got a calculator, of course, and it varies from question to question. But you can just plug it into the calculator. Be careful with the parentheses there. But as long as you keep the arithmetic straight, it's just arithmetic. Is all you need here.
Okay.
Questions about this?
Nope.
Okay.
That makes sense.
I was tempted to go over the algebra on this, and I don't know if we're going to get into all that here at the moment. But there is a way to foil this. If you're familiar with foiling, you can do that operation. I'm guessing a lot of students watching this recording are. But the easiest way to solve it, I know how to foil. Good heavens, But when I solved this, I was like, man, I'm just plugging in the values, and it works. Questions?
Nope.
Okay, great. Let's go to question number 1 now. This is another one. You sent me this question. I've seen this before on some other practice tests. Give me a second to increase the size of this on the screen. There we go. You see that question on the whiteboard?
Yes.
Okay, great. All right, go ahead and read question number 1. This one's a little tricky.
A swimming pool contains 1,000 gallons of water at the beginning of the day. A hose is turned on in the pool at a consistent rate of 540 gallons of water per hour. Which of the following equations gives the amount of water W in gallons in the pool T hours after the hose is turned on, where 0 is equal to or less than T equal to or less than 8?
Yeah, I'd read this as this is tough to interpret here, but I'd read that as T is greater than or equal to 0, and T is less than or equal to 8. That's how I'd read it. Does that make some sense?
Yes.
Okay. Let me refresh my whiteboard here in just a second. Okay. All right. Good. All right. So this is a confusing sounding question. There's just a lot of words here, right? But let's focus on what are we solving for here, Bree, with this question? What are we solving for?
W?
Yeah, which one represents W, which is what? What is W?
Water?
What? Well, it's the amount of water, right? You're right. It's water. Yeah.
Oh,
the
amount of water?
Yeah, the amount of water in gallons. Does that make some sense?
Yes.
And they just tell us that in the question. You got to kind of like really sit with that language or maybe reread a little bit, but you got to focus in on what they're asking here. Which one represents the amount of water in the pool after some number of hours, which is T? Does that question make some sense?
Yes.
Okay, good. And we know, of course, here T's got to be bigger than or equal to 0 or less than or equal to 8. That doesn't play a huge role here in this question, but let's start here. I mean, there's a way to sort of interpret this question if you know how rates work and if you're familiar with y equals mx plus b form. Are you familiar with y equals mx plus b form?
Yes.
Is it okay? Well, let's talk about that b value in y equals mx plus b. What does the b value represent?
Is that x?
Well, x is x.
Oh, so y?
It's the b. The b value is the y-intercept. is what the B value is. Is that familiar? I think I've gone over that on some other questions previously in the course, maybe on a graphing question. You can, if that's not familiar at all, if you're like, Mr. I have no idea what you're talking about, don't even worry about it. But is that familiar at all or not so much?
Yes.
Okay, all right. Do you know what the M value represents in y equals mx plus b form?
The X?
Well, the x is still just x. The M value represents the slope of a line. It also represents the rate of change, how much something is changing over time. That's the M value. If that's not familiar at all, don't even worry about it. We don't even need that actually to solve this because we can just plug in values here, actually. So let's start there. I'll explain y equals mx plus b form here in a little bit.
Because I know, like, when we have to find that mx, I usually have 2 points on the graph, and then I take like x1 minus y1 over, and then that gives me the mx value.
The M value, that's the slope, and that's sort of like how much you go up divided by how much you go over, right? But that's another way to explain
the rise over the run.
The rise over the run. It's the exact same thing. Yeah, that's the M value. So you're familiar with this, yeah. So if you can kind of keep the rate of change straight, there's a way to solve it in those terms. We'll come back to that. Let's start by just plugging in values here. Here's what we can do. We can create a value for t, okay? And if we come up with some value for t, we can sort of logically figure out how many gallons of water are going to be in the pool for some value of t, for some number of hours. And then we'll just plug that value into the answer choice and see what makes sense. Okay?
Okay.
All right. So I'm going to create a value for t here. This is really fun. I was just going over this a little bit earlier. This works pretty well. I'm going to make t equal 0. Now let's stop and think about what this means if t is 0. Okay? What does it mean, Bree, if t is 0? What's that mean?
0 time?
Yeah, 0 time has passed, right? Because t is the hours. So no time has passed. Does that question make sense? Or does that make sense? Okay. So if no time has passed, how many gallons of water are in the pool?
1,000?
1,000, right? Because it says it contains 1,000 gallons of water. Now we're adding like 540 gallons per hour. But if no time has passed, there's 1,000 gallons of water in the pool. Questions about that, or does that make sense?
That makes sense.
Okay, great. So if we plug in a 0 into the answer choices, the right answer has got to give us 1,000. Look at answer choice A. Is that going to give us 1,000 when t is 0?
No.
No. What does that give us when t is 0?
1,540?
No. Well, if t is 0, let me see you plug in a 0 for t into answer choice A. I want to see you plug it in on the whiteboard.
Okay.
Just find a clear spot.
So I would do like the whole up.
Yeah, I'd do like, you could write the W if you wanted to. W equals, I see where you are now. Zoom out a little bit. Here you go. Okay, great. Let's simplify this. PEMDAS, right? There's nothing to calculate in the parentheses. There's no exponents. We can go right to the multiplication and division.
Okay. I see what it.
Yeah. Right.
0.
Yeah, that's going to be 0.
540. Right, so it would be 540.
It'd be 540, right? Either way, it's not right? We're looking for 1,000. But I just want to, practice the arithmetic there. Does that make sense why that's going to be 540?
Yes.
Okay, so it's not answer choice A. Let's plug in a 0 for t into answer choice B. Let me see you do that on the whiteboard. Let's see what we get. Looking good. What's that going to equal?
1,000.
That equals 1,000, right? Because 540 times 0 is 0. So 0 plus 1,000, that's just 1,000. So let's keep B, okay? Let's keep testing the other answer choices, though. Plug in answer choice C. And what does that give us?
0.
0, right? It's not 1,000, so we can get rid of C. Oops, I got rid of the question there. We can get rid of C. And just look at D. Is that going to be 1,000?
No.
No way. So it's got to be B, and it is. Does that make sense how we can just plug in a 0 there to find the right answer?
Yes. I just hope I remember this.
Okay. Okay. I mean, you can plug in other values here. You can plug in a 1 or a 2. You just got to kind of calculate logically what it's going to equal. If you plug in a 1, I think you'd have, if 1 hour has passed, you'd have like 1,540 gallons total in the pool. And both A and B give you 1,540. So then you just got to plug in other values to see what works. But 0 works great there, and it gives you the answer. Another way to think about it, let's go back to that y equals mx plus b form, because if we look closely at answer choice B, I think you see now that that's in y equals mx plus b form. Okay, and I want to talk about these terms a little bit.
Okay.
That b value in y equals mx plus b, that's sort of like, if you're graphing it, that's going to be your y-intercept. It's where the line hits the y-axis, okay? And generally in a word problem, it's like your starting value, like what you're starting with. And notice, of course, we're starting with 1,000 gallons, right? Does that make sense? And we're just adding to that 1,000 gallons. So that's going to be your b value, which it is here in answer choice B. Does that make sense?
Yes.
Okay. And then your rate of change, that's your m, or the slope, it's the same thing. That's your m value. And the rate of change here is 540 gallons of water per hour. So that matches up with the 540 right here in front of the t. I know we're dealing with w and t instead of x and y, but it's still the same form of the equation. Does that make some sense?
Okay. So C and D wouldn't even be... So, like, just going by this, I could already eliminate C and D?
Yeah, absolutely, right? Because you're starting with 1,000. So you got to have at least 1,000 there. I know C has 1,000 there, but that's like your rate of change. That's like the m value for answer choice C. For both C and D, there's like no starting value, right? Because if T is 0, you don't have any water in the pool with C and D. Does that make some sense?
Yes.
Yeah. So that's another way to think about it, as but again, you don't even have to get that theoretical. You can just plug in the values and figure it out, and that works as well, which is generally what I recommend. But
yeah, it's easier.
It's easier. Yeah, there's just less room for conceptual error, if you're plugging in values. So, any questions?
No.
Okay, you're doing great. Let's keep it rolling. Ooh, this one's a little tricky. We're going to be talking a little more graphing here. Right. And go ahead and read question number 2 when you see that on the screen.
Line K is defined by x equals 2x plus 8. Line J is perpendicular to line K in the xy plane and passes through the point 0-3. Which equation defines line J?
Ooh, what are we solving for here, Bree?
Line J?
Yeah, what's the equation of line J? That's it. And they give us K right here. They say K is defined by that right there, y equals 2x plus y. J is perpendicular to that line K, and it passes to the point 0, 3. Okay, we'll talk about perpendicular lines here in just a moment. Are you familiar with perpendicular lines? They've got a special relationship. Are you familiar with that, or not so much?
Not really.
Yeah, let's go. This is on the rules document. I think I discussed perpendicular lines on another question previously, and I just got to find where it is on the rules document. Let's see. It's going to be in graphing here. Let's see. There we go, graphing. Okay. So go to basic concept B in that rules document. And there I've got a little refresher there for you. You've got y equals mx plus b form, right? Where m is the slope, that is the rise over run, b is the y-intercept. And again, the b value, the y-intercept is generally your starting value, and then that m, that's your rate of change generally. Okay. Let me know when you're there on basic concept B. You finding it?
You said
B as in
on
the on the rules document.
Okay, I was trying to figure out how to get back. Okay. Oh, the circle.
Yeah, it's right above the circle. Mm-hmm.
It's above it's not the graphing circle.
Yeah, basically there's a couple there's like 4 bullet points there for basic concept B. The first one is on y equals mx plus b form. Second bullet point, right? It says parallel lines have the same slope.
Okay.
I want you to read that third bullet point on perpendicular lines, please.
A perpendicular line has the negative inverse slope.
Negative inverse slope. Yeah, perpendicular lines have a negative inverse relationship, negative inverse slope. Okay, let's talk about what that means exactly. Let me give you an example here on the whiteboard. Let's say one equation has, I'll just make up an equation here. Y equals 3x plus 2. Okay, just making that one up. It's not, directly related to the equation in the question other than it's a line. The line perpendicular to that is going to have a negative inverse slope of the slope here in this equation. Now, what's the slope of that equation that I wrote out on the whiteboard?
3.
The slope is 3.
X.
Yeah. Well, I just say 3. The slope is 3. Mm-hmm.
Okay.
So the negative inverse of that is going to be negative 1 over 3. Okay. Inverse means you flip the numerator and denominator. Now, some students look at 3 and they're like, well, there's no denominator there, But 3 is the same as 3 over 1. Is that clear?
3 over 1, yes.
It's the same as 3, right? 3 divided by 1 is just 3. So you'll take the negative inverse of 3, or 3 over 1, same thing. So flip the numerator and denominator. You get 1/3. Make sure it's a negative. You're taking the negative inverse. You get negative 1 over 3 for the slope. Does that make some sense?
Okay, so when I flip it, I go from a positive to a negative. But then I also flip the denominator
and the numerator and the denominator. Yep, you flip the sign and you flip the numerator and denominator. That's negative inverse. Does that make sense?
Yes.
Okay.
Sort of.
Well, what questions do you have at the moment?
Like, if I were to, I don't know. I guess I just never seen it where I flip the numerator and the denominator before.
Yeah. Well, let's do it with the equation in the question, right? So look at line K. Look at line K. What's the slope of line K, which they give us in the question? Here's the equation. What's the slope of that line? The slope is 2. Absolutely. So what's the negative inverse of that?
A negative 2?
Well, negative 2 would be the negative, but we also have to flip the numerator and denominator. Yeah.
Is it 1 over? Oh, 1 over 2.
Yeah, but we got to take the negative inverse. 1 over 2
negative
would be the inverse. Negative 1 over 2 is the negative inverse. So the slope of the line perpendicular to y equals 2x plus 8, the slope of that line has got to be negative 1/2. Does that make sense?
Yes. Okay, so...
and just knowing that, we know it's got to be between two answer choices.
A or B?
A or B. Does that make sense?
Yes.
Okay, look out. If you see that word perpendicular, and we're talking about graphing lines, you're probably going to be dealing with a negative inverse slope in some form.
Okay.
So we can get rid of C and D. C and D just takes the negative of the slope. No, we need the negative inverse. Make sense?
Yes.
Okay. Now, if it's between A and B, how do we determine the difference between A and B? Well, look how they're different. Answer choice A has got a B value or a y-intercept of 3. Answer choice B has got a B value or a y-intercept of 8. Do you have any idea whether the y-intercept is going to be 3 or 8? Do you know?
No. That's just where it passes through 0-3. So it would be A.
It's got to be A because this is the y-intercept. The x value is always 0 at the y-intercept. Like graph any line, doesn't matter what line. Here's the y-intercept. Right here. Well, I'll make that 3 on the y-axis. The x value at that point is 0. Is that clear?
Yeah. So would this be the same as if we graphed the 2x plus 1 and are they flipping it? Or it's perpendicular?
Oh, yeah. Well, let's talk about what perpendicular means. Maybe that's not obvious. Do you know what perpendicular means? Like what that looks like?
Like on the other side?
Yeah, well, let's graph these. We can practice graphing here as well. So let me zoom out a little bit. Let's graph both of these lines. Okay, it is going to be answer choice A. I'll show you another way to solve this one as well here in just a moment. But it is going to be A. Okay, so I'm going to draw a little XY axis just to the right of the question. You might need to zoom out a little bit on your whiteboard. This should work. So here's our XY axis. And do you see the grid lines on the whiteboard?
Yes.
Okay, we'll just use those grid lines for, let me zoom in just a little bit. Oh, that's too much. So let me zoom out. That'll work. Okay, we use those grid lines. Let's start with the equation in the question. Let's graph y equals 2x plus 8. Okay? Let's graph, we'll graph this guy. Okay? When you're graphing a line, I always recommend starting with the b value, starting with the y-intercept. Okay? What's the y-intercept here in this equation?
Oh, where's the question? It is, you said the y8?
Yeah. Yeah, the y-intercept is 8. Is that clear?
Yes.
So we just find the point 8 on the y-axis. That would be right here. Okay? And that's your y-intercept. Does that make sense?
Yes.
Okay. What's the slope of that line? The one in the question.
Would it be up 2 over 1?
Exactly. Yeah, the slope is 2, so you're going up 2 over 1. So the next point would be up 2 over 1. The next point would be like right here. Does that make sense? Why that would be the next point on the line. We just went up 2 over 1.
Yes.
Okay. If you got 2 points, you got a line. Woo! It's going to look like that. That's the equation of the question. Make sense?
Yes.
Okay. Okay. All right. Let's graph answer choice A. It's going to give us a perpendicular line. You'll see what perpendicular means. What is the B value in answer choice A? That's the y-intercept. What's the B value?
3.
It's 3. Yeah. So you just find the 3 on the y-axis. That's right here. Let me do a different color here. There we go. That's 3. And then what is the slope?
Is that -1 over 2?
Yeah, -1 over 2. Now let's sort of interpret what that means here. A negative slope is going to be going downhill from left to right. Right? Notice that the original equation, the one in the question, y equals 2x plus 8, that's got a positive slope, so that's going uphill, left to right. If you got a negative slope, you're going downhill, left to right. So you could say you're going up -1 over 2, but up -1, that means you're going down 1 and over 2. Does that make some sense? Why you're going down 1 over 2?
Yes.
Okay. So we'll just go down 1 over 2, 1, 2. Here's your next point on the xy axis right there. So those 2 points. We got 2 points. We got a line. Woo! And there's our second line. Okay. Notice we roughly have like 90-degree angles sort of all around where those 2 lines intersect. 90-degree angle there, 90-degree angle there, 90-degree angle there, 90-degree angle there. That's perpendicular. Those 2 lines are perpendicular. Basically, if you have like a perfect X shape like that with 90-degree angles all around, those are perpendicular lines. Does that make sense?
Yes, I guess I was thinking parallel.
Ah, parallel. Yeah, parallel would be the same slope, right? Yeah, if the other equation had a slope of 2, then they would be parallel, right? Here's 2 parallel lines. Like, let me draw 2 parallel lines here. These are 2 parallel lines right there.
Okay, yeah, that's what I had in my mind.
Yeah, I got you. Yeah. Part of it's just knowing the vocabulary. But perpendicular, you get a perfect X shape, kind of like that. It doesn't just mean they're cross. I mean, perpendicular lines are going to cross, but like these lines wouldn't be perpendicular right there.
Yeah.
Notice you don't have like 90-degree angles there. You know, they're perpendicular lines are going to cross, but that's going to be a perfect X or a perfect T kind of shape. Does that make some sense?
Yes.
Or you can just look for the negative inverse slope, and that works too. There's another way to solve this, which might, at least you can get rid of some bad answer choices. Even if you're not sure what perpendicular means and you don't know how to graph things, and I know some students really struggle with graphing, and that's okay. Because they tell us that the line J goes through this point 0, 3. They tell us that in the question. Which means, by the way, we know when x is 0, the y value has to be 3 for the right answer. Let me make that a little bit more clear. When x is 0, the y value's got to be 3. Does that make some sense?
Yes.
Okay. So we could plug in that point, 0, 3, into the answer choices. And the right answer has got to give us a true statement. When x is 0, y has got to equal 3. Does that make sense?
Yes.
Okay. Look at answer choice A. When x is 0, does the y value equal 3?
Yes.
Yeah, it does. Absolutely, because when x is 0, that negative 1/2 essentially disappears. It becomes 0 plus 3. That's just 3. So that works. What about answer choice B? Does that give us a true statement? When x is 0, is y 3?
No.
No way. Y is 8 when x is 0. So it can't be B. C would give us a true statement, even though that's not a perpendicular slope, right? When x is 0, y is 3. So you might consider keeping that if you're just starting by plugging in the values. But D would give us 8 for y when x is 0. So that doesn't work that way either. So even if you're just like, you don't know how to graph anything, you're just like, hey, the point 0, 3 is on the line. You can plug it into the answer choices, and you're making a guess between A and C if you don't know anything about slope. Does that make sense?
Yes.
Okay. That's another way to think about it too. It's just plug in the point. Okay. But now that you know what perpendicular means and you know we're looking for negative inverse slope, that's how we solve it. Any questions about this one?
No.
Okay. All right. This is another one that you sent me. There we go. All right, go and read question number 3. I want to see that on the screen.
Ethan bought 3 pints of raspberries for $5 per pint and X pint of blueberries for $3 per pint. The average cost of all the berries he bought was 15 plus 3x over 3 plus x dollars per pint. If the equation y equals 15 plus 3x over 3 plus x is graphed in the xy plane, what quantity will be represented by the y-intercept of the graph?
Woo! What are we solving for here with this question?
I don't know.
That's okay for you. That's okay. Now, the thing you're solving for is generally, I mean, it's at the very end of the question. It's going to be in the last sentence. I want you to read the last sentence of the question for us. Let's focus on what we're solving for. Read it again.
If the equation y equals 15 plus 3x over 3 plus x is graphed in the xy plane, what quantity will be represented by the y-intercept of the graph?
Okay, so let me ask you again. What are we solving for here with this question?
The y-intercept of the graph?
Yeah, what it means. What quantity is represented by the y-intercept of the graph? Does that make some sense?
Yeah, kind of.
Okay. I mean, you know what the y-intercept means, right? We've been talking about that.
Yes.
Right. It's, and we could draw a little xy axis again. The y-intercept, so it's the point, on the y-axis where the line crosses the y-axis. That's your y-intercept. Okay. Now, I've got a quick question for you here, Bree. What's the x value at the y-intercept? It's always the same for any graph. What's the x value at the y-intercept?
0?
It's 0. Absolutely. Doesn't matter what line you draw. I'll draw another line. There we go. The x value at that point, the y-intercept is 0, no matter what the y value is. The x value is always 0 at the y-intercept. Does that make sense?
Yes.
Okay. So they're asking what quantity is represented by the y-intercept. I don't know what the y-intercept is. I don't think you need to know it here. But I know what the x value is at the y-intercept. The x value is 0. It has to be the case. Does that make sense?
You said the x is 0?
X is 0. Always at the y-intercept. Always. Does that make sense?
No.
No. Well, what's the y-intercept right here on that line? What's the x value at that y-intercept?
The x value, I think I is confused, is 0. Yeah, it's on the on the line.
Yeah, it's on the line. Yeah, if it's touching the y-axis, that point there, let's say that's like the point 0, 3. The x value there is 0. And let's say that's the point 0, -2. The x value there at that point is also 0. You draw any line, and it's going to, if it goes through the y-axis.
Oh, okay.
The x value at the y-intercept is always 0. It doesn't matter what line it is. It has to be the case. Does that make sense?
Yes.
Interestingly, the y value is always 0 at the x-intercept.
Okay, yeah, now I get it.
Right? So those two lines, right, where the line crosses the x-axis, the y value is 0. And I've seen some questions where you kind of need to know that idea. The y value is 0 at the x-intercepts, and the x value is 0 at the y-intercept, always. Got it?
Yes.
Okay, good. So we don't know what the y-intercept is exactly here, and I don't even know how to, well, we could calculate it, I guess, but I know what the x value is. The x value is 0. It's got to be. Make sense?
Yes.
Okay, now what does x represent in the question? They tell us a little bit earlier in the question what x represents.
The pints?
Yeah, the pints of blueberries.
Yes.
Okay, they tell us that. It's the pints of blueberries. And then they give us this equation that says the average cost of all the blueberries he bought was this equation here, dollars per pint, the average cost. Well, basically, right, and we're trying to figure out what quantity is represented by the y-intercept. If we plug in a 0 for x, that will give us the y-intercept. If we plug in a 0 for x.
Or...
Does that make sense?
Yes.
And that'll tell us what the average cost of all the berries is when x is 0. And that means, by the way, there's 0 pints of blueberries, which means it's all raspberries. Does that make sense why we know it's all raspberries if x is 0?
Yes.
Okay, great. Look at the answer choices because I think that's enough to help us find the right answer.
The total cost and so I know it's either A or B.
It's either A or B, right? Because he's not buying any blueberries if x is 0. Does that make sense?
Yes.
So we can get rid of C and D right off the bat. We're not talking about the cost of the blueberries. It's either A or B. Now the question is it the total cost of all the raspberries or is it the average cost of all the raspberries? That's the question. But if you read the question carefully, you can figure out which one it's going to be.
The A?
Why A?
It says for the 3 pints of raspberries for $5 per pint.
Yeah, but look at the next sentence in the question that I've underlined in green.
Oh. I'm confused.
Well, look at the next sentence where it says the average cost of all the berries he bought was 15 plus 3x over 3 plus x dollars per pint. The average cost, not the total cost, but the average cost.
Oh, so it tells us in the
question. Yes.
That it would be B.
Yes. So it's got to be B. Because that expression, when x is 0, will give us the average cost of all the raspberries. Because there's no blueberries. Does that make some sense?
Yes.
And that's really kind of pay attention to the wording of the question there. If the question said the total cost of all the berries he bought was 15 plus 3x over 3 plus x, then you could go with A if it said that was the total cost. But it's not the total cost, it's the average cost. So it's got to be B, which it is.
That makes sense.